When we take a look at acids and bases, it's important to first identify what is an acid and what is a base. An acid, we're going to be working with the definition that talks about acids as being hydrogen ion donors. So they give off a hydrogen ion or they accept an electron. So all the ones that we're going to be working with are hydrogen ion donors. So that means that they have to have an H plus ion in the formula. So things like hydrochloric acid, acetic acid. Another key if you're talking about the name of an acid is that it has the word acid in the name. So that can kind of help you. Most acids also have the H first in the formula. Occasionally it will be last, but most of the time it's going to be first in your formula. So you have your HCl, HBr, H2CO3. So notice we've got a hydrogen ion that's first and with a negative ion, so chloride ion, bromide ion, carbonate ion. So do be careful that it can be either a single ion or it can be a polyatomic ion. For bases, they accept a hydrogen ion, so they're the opposite of the acids, or an electron. They donate an electron. And they often have a hydroxide ion in them. So sodium hydroxide here is a base. Ammonia here is a base. So these are ones that accept a hydrogen. So the sodium hydroxide can accept a hydrogen. We'll look at what that type of a reaction looks like. If we look at some of the properties of acids and bases, acids are sour. So like I've said before, includes an H plus in the formula. They turn litmus paper red. We'll take a look at that with an actual experiment later. And make sure and review back in your nomenclature on how are acids named. How do we name them based on the ion that they are with? So how do we base their name on the anion that's with it? So remember, anion is our negative ion. So we have some sort of negative ion with H plus. So H plus and Cl minus is HCl. So hydrochloric acid. So it's based on what the ion is it's with. So do make sure and review your nomenclature. So this is nomenclature part 1. This is how you can look at the naming of acids. For bases, these are bitter compounds. They have a slippery or soapy feel, so soaps are typically basic. And they turn litmus paper blue. So we'll take a look at litmus paper as well in the later on in the course. They often include hydroxide ions in their formula. So if you have a hydroxide compound, that tends to be fairly straightforward. So for naming, if we're talking about hydroxide, that means it's a polyatomic ion with a metal. So you typically have a metal cation and hydroxide. So let's take a look at a little quick naming review. So these are some acids and bases. I suggest that you take a moment to pause the video, check and see whether you can come up with the names for all of these. And I'm going to show you the answer in just a second here. Right? And the answer to these is here. So HCl is hydrochloric acid. It's a binary acid, so we use the hydro before the name. It's a chloride, so it becomes chloric acid. Potassium, hydroxide. So potassium is a main group metal cation, so we just name it based on the name in the periodic table. Hydroxide is always just hydroxide. Calcium hydroxide, same type of thing. It's a main group metal. Here, H2SO4. SO4 is a polyatomic ion. it's sulfate, and 8 becomes ic, so it's sulfuric acid. The iron, this compound, we have iron and we have a hydroxide. Because this is a variable charge metal, we have to determine the charge on it based on the number of hydroxides. So hydroxide, we have OH minus, and there's 2 of them. So that means we've got 2 negatives. So the iron has to have 2 positives to cancel that out. So it's iron 2 hydroxide. This last one, same type of thing, except we've got 3 hydroxides here. So we need 3 positive charges on the iron to cancel out the 3 negatives from the hydroxides. So it's iron 3 hydroxide. So do make sure that you review your naming of acids and bases.